Question 8 asks us or instructs us rather to copy and complete the area models below. So part of the your task is to just accurately sketch these 4 area models and then go ahead and figure out the either the dimensions or the areas inside. So if I take a look at number 13, I'm sorry, if I look at part A, you can see that it has 13x minus 21 as the length of one of the dimensions, and the other dimension is 6. When I multiply 6 times 13x, I get 78x. So part of my answer is 78x. And when I multiply 21 times, I'm sorry, negative 21 times 6, we get negative 126. So this is I've completed the area model here. The instructions then say, let me bring this back out here. It says, then write each area, um, then write the area of each rectangle as a product equivalent to a sum. So what's meant by that is the product we're looking at is 6 times 13x minus 21, right? I'm multiplying 6 times this other dimension. That's the that is that's the area expressed as a product of 2 dimensions, and then it is equal to the sum of these parts. So it's equal to 78x minus 126. And if you look at it closely, right, for this simple problem, you can see that it's a matter of an application of the distributive property, right? 6 times 13x and 6 times negative 21. For B, it's a binomial times a binomial, so it's a little bit more involved, not much. If I was going to start by writing out this as the uh, the area as a product, right, that would be x minus 5. That's one of the dimensions, the one that runs up and down. And the other dimension is x plus 3. So what I'm doing here is multiplying x minus 5 times x plus 3. And when I look at that, the first one I might write, I'll circle this in red. Whoops, in red. When I multiply x times x, I get an x squared. When I multiply the negative 5 times x, this is negative 5x. When I multiply I guess I'll do the positive 3 times the x, I get a positive 3x. And then finally, the last one I'll just do in black. When I multiply negative 5 times 3, I get negative 15. Now, when you look at this, 2 of the terms in each of the 4 boxes, 2 of them are identical, right? They're both x terms. I've got negative 5x and positive 3x. Those 2 can be combined. The other ones are all different. They're not like terms, so we'll write them separately. So my answer would look like, first of all, the x squared. So I've got x squared, and then I would say a minus 2x, and then finally a negative 15. Um, and I think that's enough that I think you should be able to do. Well, D you should definitely be able to do. If I look at C, there's probably a couple different answers I could come up with, but the one thing that I would do is try and identify the value that I can divide um, all 3 of these with. You'll notice it's a little bit different. This time we're starting out with the values inside the boxes. Well, if I look at 16, negative 24, and 4, all 3 of those may be divided by the number 4. So I could just bring a 4 outside of the box, right, and then divide each one of these terms, this term, this term, and this term, by 4. And when I divide them by 4, in the first case, 16x squared divided by 4 is 4x squared. Negative 24 divided by 4 would be negative 6x, and then 4 divided by 4 would be 1. So you can see one of your dimensions is 4, and then you're multiplying that times 4x squared minus 6x, and then plus 1. And then just write down what that area is as the sum of the pieces. So you can finish B and D on your own, I'm confident.